Okay, let's just go over some tests for organic compounds. If we want to test for an alkene, we can carry out what's called the permanganate test. What we do is we take a sample and we put some of the sample into a test tube. Then we add about 10 drops of permanganate, MnO4, and we shake. If there is an alkene or a double bond or an alkyne, a triple bond present, if the molecule is unsaturated, the purple solution will turn brown. This is the positive test for unsaturation or for a double or triple bond. What we can see here is actually the alkene bond here is turning into two OH groups, or an alkene is undergoing an oxidation reaction and becoming a diol. Okay, the bromine water test is a test that we can do to identify if a molecule has a double or triple bond or if it is unsaturated. What we do is we take maybe 2 milliliters or 2 cubic centimeters of the sample, we put it in a test tube, we add about 10 drops of bromine water and we shake it. Now this orange bromine solution will go colorless if the double bond is present. Now what's happened in this reaction is the double bond has broken, and then the carbons that were part of the double bond then attach themselves to the bromine atoms, and we produce this haloalkane. So the alkene has undergone an addition reaction to produce a haloalkane. Okay, if we want to test for an alcohol, one of the tests that we can do is called the Acidified Permanganate Test. So we take some permanganate and we acidify it by adding some sulfuric acid. And so we take our sample that we want to identify if it's an alcohol or not. We take a few milliliters of it and put it into a test tube. We add some of the acidified permanganate. Now we can either do that by having the permanganate acidified initially, or by adding some permanganate and then a little bit of acid. And then we take that sample and place it into a hot water bath, usually about 60 to 70 degrees Celsius. We heat for 5 minutes, and if it goes colorless, that means an alcohol was present. So this is a positive test for an alcohol. It goes from purple to colorless. What's happened is the alcohol group has been turned into a carboxylic acid group. Okay, so if we want to test for an alcohol, one of the tests we can carry out is the Acidified Dichromate Test. Now this will specifically test for primary and secondary alcohols, and it will also for aldehydes. If we take a sample and put it into a test tube, we can add the acidified dichromate, usually about 10 drops. It can either be added as dichromate and then some acid added, or the solution can already be acidified. We add it to the solution goes orange. Now we take that solution, we place it in a water bath of about 60 to 70 degrees Celsius, and we leave it for 5 minutes. What will happen is if the alcohol is present, the color will change from an orange through a browny color to a green to blue color. So we'll get this greeny color at the end. What's happened here is the primary alcohol has been oxidized to a carboxylic acid. Amines. Okay, so if we want to test for amine, the common test is to use red litmus paper. Now what we do is we take water, just some water in a test tube, and we add a sample of amine to it. We give it a shake, so we've got a solution of amine and water, and then we take our red litmus paper, we place it, dip it in the solution, and if it goes blue, that's a positive identification of an amine. So what's happened here is our amine, as it is at equilibrium with the water, it produces the hydroxide ion, and the hydroxide ion is what turns the litmus paper from pink to purple. So the amines are weak bases, and they've partially dissociated with water to produce hydroxide ions, and that is what we identify. Okay, amines, this is not a definitive test, but they often have particular smells. So small chained amines smell similar to ammonia, but as the number of carbons get larger, they smell a bit more fishy, right? So if you can think of cleaning ammonia, they smell a bit like that. If we have diamines, which is two amines on either side, they actually get very peculiar smells. So we get this chemical called putrescine, which is got an amine on the first carbon and an amine on the second carbon. So you could call it propan 1,3-diamine, and we get this as this molecule, and we get cadaverine, which is 5 carbons with 2 diamines. Now they are actually both major contributors to the smell of rotting fish and meat. These compounds are produced when we break down proteins and amino acids, the amino acids in protein. Okay, the test for carboxylic acids, a common test, just a quick test to see whether we may have an acid, is called the blue litmus test or litmus test. We take water, we add a bit of our sample, and we mix it. We just shake it. We then take that sample and we dip in blue litmus paper. If it goes pink, it means it's acidic, and it's a good chance we had a carboxylic acid. This is not a definitive test, but it does indicate that there is H3O plus ions present, and it indicates it's probably a carboxylic acid if we're just testing between a few known samples and we want to identify. If we want a definitive test for carboxylic acid or a chemical test, we usually add sodium carbonate or sodium hydrogen carbonate, sodium bicarbonate. We take the sample, we add a solution of our sodium carbonate, and when the solution is added, we get this effervescence, or these bubbles produced. These bubbles produced a carbon dioxide gas, and this is a positive test for a carboxylic acid. Now what's happened here is the carboxylic acid has reacted with the carbonate to produce carbon dioxide gas. Carboxylic acid. Well, carboxylic acids have odors, a specific type of odors. Usually we describe these odors as being sharp. That is, they're very aggressive on the inside of your nostril. They smell like a strong vinegar smell. Let me get this up. The smell of vinegar, that's ethanoic acid. That's this part of the molecule contributes to it. There's also another strong smelling, very strong smelling, sort of unpleasant smell of butanoic acid. You might notice, or you might actually get a chance to use some of this in your chemistry class. This is the smell of rancid butter, and actually the butanol, the alcohol that comes off of butter, is the reason it's called butanol is because it's named after butter where it was found. Okay, we can use the solubility of substances to try and further identify the size of the molecule and what functional groups they have attached. Now what we do here is we take a sample of water, we add to that our unknown sample of organic compound, and then we shake it. If we get this single layer, it means it is miscible. That means it's completely mixed and the solution is soluble. If we have a soluble solution, it could be one of the following three: an alcohol with 1 to 4 carbons, an amine with 1 to 3 carbons, or a carboxylic acid. Can also be other compounds like aldehydes and ketones, but if we're just doing simple identification of a limited range of organic compounds, we usually don't need to remember about those. Now the reason this is soluble is because organic molecules form hydrogen bonds with the molecule, with the water that they're placed in. See these ones that are miscible, the ones that are soluble. So insoluble. We have a certain number of compounds that are always insoluble. That means if we add the sample to water and we shake it, we still have 2 observable distinct layers. They are said to be immiscible, and that means they don't dissolve. Now the ones that don't dissolve are always organic compounds with 6 or more carbons. So if you have 6 or more organic compounds, you can't dissolve in water well enough, so you won't see 2 layers. And generally all alkanes, alkenes, alkynes and haloalkanes are insoluble in water.